Hello everyone, welcome to the second session of VoLTE training campaign. In today's video, we are going to cover 2 points which relate to the registration capabilities for the IMS and the VoLTE in general, and this will be covering the end-to-end call flow for different aspects, including the IMS and even the 4G attach and so on. We'll go through details in next slides. Then we'll be ending by the end-to-end mobile originating call flow from the IMS point of view, and this will simplify the next sessions about the details of the end-to-end call flow, including the signaling points and so on. So let's move forward to see what we have. So before jumping into the details, I would like to recall what we have ended by in the previous session, which is related to the high level of the VoLTE call procedures. As you remember, I mentioned that it's being split into 4 parts. The first part is about the attach, 4G attach. Initially, once the users get connected to the network, you need to attach to the ABC on the 4G network in general. So we'll explaining the end call flow and some of the message contents. And the most important, it's about the capabilities of the voice domain and so on. So if you look into this figure in the top right here, this is just showing high level view of the attached request message, which is including a lot of information, including the attached type, EPS mobile identity. For example, the user need to send his identity either using MZ or GUTI. We explain whenever he can use MZ or GUTI, and he need to send his capability, which is highlighted by red color, to let them know about his own capability. And also he need to give some information about the voice domain preferences for the user himself. This is will be explaining in some details, especially the last point here. And here it's about some information about the BDN type. For example, he's supporting which IP version, for version 4 and 6, or both of them and so on. And the second part, it's about the BDN connection. Once the user did the attachment, the attach to the ABC network, he now need to request for the IMS APN and also you need to acquire the BCSC IP in order to be able to start the registration to the IMS network. So here it's like PCSF discovery, as you can see in the bottom right here, and we'll explain the call flow as well and the contents. As you can see here, this is IP address. Then the third point, it's about the IMS registration. Once he got the QCI 5, now he opened the channel, he can start communicating with IMS, but he needs to register himself first to the IMS. So he will go through the end-to-end call flow as shown in the writing. Then we'll be ending about the high-level call view, which is very interesting part. This is one of the most important. It will facilitate that make it you make understand easily about the call flow in general. So let's move forward for the next part, which is related to the 4G registration or 4G attach. Okay, this is actually here we're going to explain the end-to-end call flow for the attach in the 4G. And actually, the main idea that the users, whenever is going to make attach, the main idea here and the most important information which you need to know about, which related directly to the VoLTE, it's related to the VoLTE preferences and so on, and IMS preferences, which is usually including the attach message. But it's also important to understand the overall call flow. So let's see what we have. Initially, when the user does attach, he will send the attach request as shown here. It will go through the inode B. As you can see, this dotted line. Means it's transparent for the inode B because this is NAS message. So it will go through to the MME. And usually this message will be piggyback in the S1AB initial UE message. So you will find a message called initial UE message sending from the inode B to the MME, and this one including the attach request which is being sent by the user because this is using its NAS message. And this attach request actually including many important information. We'll go through the most important which related to the VoLTE. For example, the UE identity and capabilities, and also the usage settings which related to the voice domain in general. And this is will be our focus point in the next slide, which contain the details about that. Once the attach request is being sent here from the UE to the MME, the MME, after he received the attach request, he need to acquire some information or to collect some information from the HSS about the user identity, for example, his location and so on. So what will happen? He will send the MME send something called ULA, which stands for update location request. This is including actually what kind of RAT, for example, is coming in 4G, and also the MZ or the GUTI information for this particular user, which is being reported and attached. So the MME is requesting to HSS to share this kind of subscription data for this particular user, and also all the related features supported for this user, especially for the HSS features. So the HSS will be replying with the subscription data, and the supported feature. So as you can see in the point number 2 here, the once the MME triggered this diameter update location, which is actually the HSS will now return the MME. It will send the quality of service for this particular users, which is being returned in the HSS, and also the geographic position, which was already shared. And also at the end, it will inform the MME that this user is being allowed to attach to the network or not. There is no restriction, for example, in this particular user. And actually, once and during this message, the now the HS can store updated information about the user location once in this particular ULA. And this is ULR. This is the response for the update location response. So this is very important as well. Actually, in between, there is some authentication security messages should be there as well to make sure the user is authorized to access to the network and also the authentication process, but I just excluded for simplicity point of view. So once this one is being received now, the MME need to send to the serving gateway something called create session request, as you can see here, create session request, and this actually message should go to the BGW, and this is requiring that the user would like, the MME would like to open a tunnel with the serving gateway and BGW as well, but since there is no direct communication between MME and BGW, it will go through the SGW. So if you look into that part, the create session request, including a lot of information. One of them is the MZL for example, the MME ID for the control plane. Actually, the MME is telling them that my GTP or the tunnel endpoint control plane is it's informing them about its GTP tunnel endpoint. And the tunnel endpoint or GTP in general, it's like the radio bearer between the UE and the inode B, which you use to carry the traffic, for example, or the signaling and so on. So this is like informing them that it would like to open now to have a tunnel between the serving gateway and MME and also the packet gateway. And also it's telling the serving gateway about BGW address IP to make sure that the serving gateway will forward this kind of message, which is create session request, to the appropriate or the correct BGW. And also about the BDN type, which is being sent in the attached message. BDN type, actually, it's just the user was telling them that I'm supporting, for example, IP version 4 or IP version 6. In case if user supporting both of them and the network supporting IP version 6, so the user will be selecting IP version 6. This is in case of that. And the IBN type, for example, this is initial, it will be, for example, for data or web or whatever, and RAT and quality of service. So the same message will be forwarded from the serving gateway to the BGW with the exact same content. So the next, actually after that, the BGW will be responding with create session response as showing here for this create, and now it will be do the same information. Now do you want to have end-to-end to open end-to-end channel in terms of GTP or the tunnel endpoint? So it will tell them my IP is XYZ and my tunnel endpoint for the user plane and control plane, UB is user plane and CB is control plane, is this is my tunnel endpoint. So now this connection or the tunnel end-to-end tunnel endpoint or GTP is being now created between the serving gateway and BGW. And it will tell them what kind of BDN type is being selected. For example, IP version 4 or IP version 6. And it will give them information about the quality of service and the BS peer identity in general. For example, which QCI is going to be used, what kind of information for the quality of service and so on. So the serving gateway will return the same information to the MME, but it will add some information on top of that. For example, here it will add its own IP addresses for the serving gateway to the MME to make sure the S1 connection is being created, and also it will add the TE tunnel endpoint for the packet gateway as being sent here for user plane control plane, and the remaining information was just being mentioned. Once this message is being received, the MME need to communicate back to the inode B through asking the inode B to start creating the context for this particular user. So now it will be sending this initial context setup request, which is actually the equivalent to attach accept message and active default ABS period request. So in this message, actually, it will include almost the same information which being sent here, except for sure the TED or this kind of information just between these three entities. But the most important, it will have the ABS period, quality of service, and also the MBR messages. And this is in the error interface, you'll find this one called attach accept and also activate default EBS peer request. By the way, in the attach request, this is also related to the BDN connection request message. So, and this is both of them is being piggyback in the initial UE message. So once this message is being sent to the UE, Now here, this will be the bearer will start like creating the bearer for this default bearer between the UE and the init B. Once it's being successful being done between both of them, the init B will responding back for this initial context stop request with initial context stop response, which is now it need to tell them what kind of my information. For example, what kind of my init BT ID as well, just to to open a channel now between the init B and serving gateway as S1U, right, user plane between the init B and the serving gateway. So it need to send, it's also a GTP tunnel endpoint. And it will then tell that your downlink path now can be to open the downlink path from serving gateway to the init B, and need to tell them about its own IP and tunnel endpoint. So this is the main point here. After this message, actually, the UE will now send directly to the MME through the next message that, okay, attach is being completed, and now the default bearer is being activated, and attach being completed now successfully. So the last point now, which is very, very important, as mentioned here, after all that, the MME need to inform the serving gateway about this kind of information, which is the init tunnel endpoint and the IP, which actually being completed after the setup. And the main idea to make sure that now the uplink and downlink path is being created between especially the init B and the serving gateway for the user plane part. So it will, last point here, you can see it will send modified bearer request, which is sending all the information about the BS, which is being already acknowledgement in 8 and 9, and the information about the init B, which is the tunnel endpoint, and the IP of the UE, the init B. So now this process is being completed for the registration. Now, next slide, we'll go through the details about the directly related information to the VoLTE call engine. So here I would like to take you for very, very important information. It's related to directives of VoLTE. For example, if you would like to confirm or to check during the troubleshooting or in general what kind of capabilities we have in the network, even from the U side or from the network side. So we need to check the attach request message. This can be checked from drive test and example, or initial UE message from the S1 AB traces in case if you have Wireshark or you have traces being open for both of them. It will both of them almost contain the same information. But the most important information related to the VoLTE, it actually need to look into two parts. As you can see in the right side here, you have something called voice domain preferences and UE usage settings. You'll find two pieces of information under that part. The first one called UE usage settings, whether it's voice centric, and this is having two types. It's even voice centric or data centric. For example, the user it's himself, even the device or the SIM card is not supporting voice at all. So he will be sending data centric. So in this case, he is not able to perform at all. And the second part, for example, the voice domain preferences for EUTRAN. This one actually having four domain or four types. I will explain the 3GPP definition shortly about that part. But for example, it can be CS only, which means it will be CS fallback, and it can be IMS, as you can see here, IMS PS voice preferred, and CS voice as a secondary. So the preferred one is IMS, then followed by the CS. I will explain what it means by this through some flow now, but this is just keep in your mind that there is four types of the voice domain, but the one which you use usually it's IMS being preferred and CS as a secondary. Then this one is just the UE is telling the network the the core network about its own capability. So it's telling them, yes, I'm supporting this service C2G RAN and UTRAN. The capability is being supported. So it's telling them their capability. Once the MME receive this message, it's need to respond back about the network capability itself as well. So for example, in the second message you can see down here, attach accept message, I'm highlighting the most important information to the VoLTE in general. You can see it's sending something called IMS, voice over BS, is being supported. So now the core network is confirming its own capability that I'm supporting IMS. So in case, for example, you find that here this information being sent as IMS prepared, but the IMS replied was not supported, this means the IMS or the VoLTE call is not being supported, and you need to check with the core team what kind of actions need to be done from the core side. So now let's explain what it means by this in more details, voice-centric and IMS voice preferred. Okay, as you can see in the two figures in the left here, the first one here in the top left is showing that the voice domain preferences can have four types, as I mentioned, this part. It can be even sent as CS only or IMS only or CS preferred and IMS secondary and IMS preferred and CS secondary. And this is the one usually used for the VoLTE network or the IMS. So the first one, CS only, means CS fallback only. And this one means, for example, CS preferred means that the CS or CS network is CS feedback is more preferred compared to IMS, and this is the opposite way around. So how this works actually, we have this two piece of information, something called US voice centric, and the second one for that part. So I just quoted one example from the 3GPP. As you can see here, the user initially set his preferences as IMS PS voice with CS voice as secondary. So the IMS is being preferred and CS is secondary. So what the network will do? Initially, the user will be sending this message. So the user will initiate this combined EPS MG attach procedures, and if the attach is being accepted as showing here, attach is, and there is no indication from the core network that CS fallback, for example, is preferred, CS fallback is not preferred. So what we'll do, the UE will check this kind of message, which is the network capability, whether it's being supported or not, IMS VoIP over PS. So a UE checks for IMS voice PS session supported or not. If it's supporting, then it will. If it's not supported, it will use CS fallback. But in case if it's being supported as showing here, it will use directly the IMSP's voice, which means a VoLTE call. So it's depending on this message. So in case if the attach is being failed or not accepted by the network, again the UE will go and check the capability of the network. So if assume that the main network mentioned that it's not being supported for the it's not supporting to have IMSPS. So now this is the second piece of information will come into the figure, which is now the UE will check, the network will check this kind of information, which is for example centric. If the UE checks first his voice centric or data centric. So once the UE check this part, for example, he found that he's voice centric. So as long as the IMS is not being supported, he will select back to other RAT, for example to 3G. But if it's data centric, means he cannot initiate any calls, so we'll stay in RAT and in the same technology, which is for example the 4G, and the call will fail. So this is the overall flow, and you can find all the details about this, the remaining four, if you'd like to go through details through this kind of version 3GP. So now let's move to the next part. So once the UE completed his attach, the first attach. After that, as you can see here in the top left here, the user completed already the attach, which is using the VoLTE QCI 619. Now, the user need to initiate another attach or another BDN connectivity request, requesting for the IMS APN, and also he would like to get the proxy CSCF IP for the IMS in order to be able now to start the IMS registration. So actually here in the top right here, the right and the further right, this is end-to-end call flow. It's exactly same, almost the same as the registration. For example, initially you will send the BDN connectivity request, requesting the IP address of the proxy in this particular message. I will show this one in the next slide in details. So requesting that I would like to get the proxy CSCF IP in order to be able to communicate with the IMS network. Then again, the MME will start following the same process which being explained in the 4G attached message. It will send create session request for the serving gateway, which is including again the tunnel endpoint, and also adding the information about the BDN type, the IP, and also requesting the, which is the most important here, requesting the proxy CSCF. And this message will be forwarded to the BGW, including the same information. Then here there will be something called IP CAN between the BGW and BCRF. The IP CAN actually it's abbreviation for IP Connectivity Access Network. And the BGW is just asking the BCRF, okay, now we would like to get the information for the APN, which is IMS QCI 5. So I need to the BCC rules, and the quality of service information about the QCI 5. So the BCRF will be responding with this kind of information. Then after BGW receive the response, it will send create session response to the serving gateway, which including the information about the IMS APN and the QCI 5 information, and also the information about the IP of the BCSCF in general. And also it will sending, if you remember, we mentioned that the tunnel endpoint for the GTB. So it will for its own tunnel endpoint in order to create the new tunnel or new GTB to call between the serving gateway and back 5 for that part, because we need a new tunnel endpoint for the QCI 5. The first one was QCI 6 to 9. Then it will follow exactly the same what we have mentioned before until it's being complete. Then actually what I would like to discuss with you in details, it will be about the BDN connectivity request, what kind of information which you have it here, and how the UE is getting the information from the network, as we just mentioned here, and what is the message content. So let's move to the next slide. So now let's see what we have as the content of this message. For example, here, the BDN connectivity request, if you open this message, you'll find in that part it's showing that the UE is requesting, okay, I would like to get the information first, my BDN type. I'm supporting IP version 4. And here, this is my access point name, which I would like to get information about it, which is IMS. Then within this message, you will find also that the user himself is sending proxy CSCF IP version 4 address request. He's requesting, I would like to get the address of the BCSCF, which is, if you remember, this was the first point of contact for the IMS. And the user would like to get that part to start doing this third step, which is the registration to the IMS. So here it will be sending the request. Once he receives the response from the unit B or through the steps which we just explained previously, it will say he will receive this activate default EPS period request. And within that part, you'll find that it's having information about the IMS now and the quality of service, and also it will give them the address now. It will tell them, okay, this is the proxy CSF IP version 4 address. You'll find the address here, and this is usually they call it proxy CSCF discovery. So now the user he's aware about the IP. He can start communicating with the IMS in general to start doing the registration to the IMS. So after that part, the user will start doing the registration, which will be our next part. We'll discuss about the end-to-end call flow for the registration and also the signaling contents of the registration. So let's move forward. So once the users got the BCSCF request IP address, now he can start communicating with the network. So the first on the left here, this is the user himself. This is the UE. So is the user now need to get SIP registered or make the registration for the IMS. So the question which you might ask yourself, why the user need again to do registration or attach to IMS? Actually, the IMS, even the registration or the attach being completed for the EBC side, for the IMS itself, the user is still not being authenticated or authorized to access the network. He needs first to get registered to the IMS. So here we are going to explain. As you can see here, the first step, what will happen? The user will send a SIP register message to the BCSF. If you remember in the previous session, we were explaining about the function of the IMS entities. We mentioned that this proxy CSF is actually acting as the first point of contact. So all the messages need to go through the BCSF first, through the UE, then it will be forwarded till it reach the C. I added in the top right here what is CSCF abbreviate stands for. It stands for call session control function. So the first point of contact, again, as mentioned before, in the function of the IMS, is that the proxy call session control function is acting as a first point of contact. So it will receive the SIP register. The SIP register, actually, includes many important information. I will go through them in details in the next slide. But just here, I will just give you a high level what kind of information which is mandatory to be known by the proxy CS. The first information is two pieces of information. The first one is IMBI, IMBU. This one, actually, the first one is abbreviated for private user identity, or IMS private user identity. And actually, this is used for the authentication and also internal working within the IMS itself. So this is like identity, but it's a private one, which is used by the IMS. The second one is stands for IMS public user identity, and this is like for any external communication between the IMS entities and any other entities. So the first one is similar to the MZ, for example. So yeah, this is the main idea. The third information, the UE is telling the BCCF or the proxy call session control function its own IP address. It's telling this is my IP address, where whenever you would like to send any response or any feedback, you need to send it at this particular address. So now the same information will be forwarded from the proxy CSF to the interrogating call session control function, which is IC. The main idea that actually it cannot be forwarded from the proxy to the interrogating directly, because still the proxy doesn't know what the IP address of the interrogating CS here. So the proxy call session control function need first to query the DNS, asking them about asking or getting the IP addresses about the ICCF. So once it's got the IC using the SIB URI, which is being included in the SIB register, what is being sent to the DNS will be now telling them you can send it to this particular IP address. So it will forward the same message here. Then the ICCF actually need to do what? It's need now to go and query from the HSS, home subscriber server, about the IP address of the serving call session control function for this particular user. So it will send this user authorization request. And as you can see in the top right here, this is requesting for the authentication information. And the second part is requesting for the information about the serving call session control function. Actually, what is this authentication information? This one actually it's telling them that I would like to get the authentication information for this IMBI and the MBU, giving this two pieces of information to the HSS, asking for this kind of information, which means that what giving them the IP addresses or the this information that asking them that this what is the SCCF serving this for this particular user. So now the one this being done, that will respond back to the ICF, giving them the address of the serving command control call system control function. It will sending this sub register, and now the ICF knows where is the serving SCCF where. For example, assume you have in the network 4 serving call system control function. So the HSS will tell them that this particular users is serving, for example, can be served by the SCCF1 or 2 or 3 or 4. So this is the main idea why the interrogating CSF is invoking or interrogating the HSS to get the information about the serving call session control function. Also, other important information that the HSS check, not only the serving command control session function, it's also checking this IMBI and MBU to check that this user is authorized or not. Maybe the user is restricted or blacklisted or whatever. So this is just a confirmation also of the information which is being communicated to ICSF. So once he received the address, it will forward the same information from the ICF to the serving CSCF. Then the SCF actually will check this user is being authorized to access the network or not. As you remember, and also the function which being mentioned in the previous video, that one of the function of the serving call session control function is to do the registration or complete the registration for the IMS for the users. So now the serving will send multimedia authentication request to JSS, and this will include a piece of information also for the user identity. Ask them, please give me the authorization vector of this user. So actually what it means by authorization vector, what kind of information it's requesting the HSS to provide. If you look into here, the authentication vector is actually consisting of 5 things or 5 points. First one is random number and this authentication vector. And this is the network response, something called X response, and the ciphering and integrity keys, which is being required from the this all information will be included in the multimedia authentication answer. Actually, this is authentication called authentication token, and this is usually generated by something called master key. And in summary, this information just being used by the SCCF to start challenging the users about his authentication is being able to access the network or not. So it will send this kind of information to the ICF, then it will be sent to proxy CSF, but the proxy CSF will filter out this information, especially for the they call it CK and IK, which is a ciphering key and integrity. It will just it will be saved within the proxy CSF, and it will just be forwarding these two information, which is user identity and the random here. Then what will happen? The user now will add some information. He will send in the sub register his own response called signal response, which also the user is what the user is doing. Actually the users also can generate his own authentication vector and through something called master key. So he will compare whatever being received from the SCCF with the one which is being generated by the users. If both are equal, this means he's authorized. So he'll send again a new sub-register, including his own response that yes, authorized to access. He will send this one, which is called signal response. And also, again, he will include his UIP address, asking me, please send me the feedback at this IP address or the acknowledge at this IP address. Then this message will be forwarding. And the last step here, the SCF, once receive this information, he will compare this RES, which is signal response, with the X response from the network. If both are equal to each other, then this means the user is being authorized. And the last step that now the serving call session control function need to inform the HSS to update its own database that I will be serving these users all over the way for the meantime. So it's just asking them to update the information and to restore the new information that I'm the one who's going to serve this particular user. Then it will be just sending acknowledgement to the user. So this is just the end-to-end call flow. Now let's go through the details about the sub register message, which is going contain very important information which you need to understand about it. Actually, here I just take the figure which is the endpoint for between the user and proxy CSF, And here we'd like to go through the details, especially for the SIP register message. You can see in the bottom left here where we have the from the drive test, or even from the, if you have prop, or if you have prop, I mean from traces being captured from the IMS side, so you can check from the Wireshark, you'll find the same information. So here you have four information, as you can see. The first one was the first SIP register, which is this one. Then you will have the response, which is 400.01 unauthorized, which is the proxy or the serving CSF is challenging the users. Then it will have the response from the users. Then again, it will be ending by 200 OK, which is acknowledgement, which is telling the user now you are registered to the IMS network. So let's explore quickly what is the IMS register information. Let's zoom in here and right here. If you zoom into this part, you will find that first part here in the first sub register, it's having this register message, which is actually meaning that, okay, this user is sending, now this is just telling them that I'm trying to register to the SCSF, so it's sending this request to the BCSF. And as you can see here, this is including many information as a method. First, the method is register. I would like to register to the IMS network. And after that, it's just giving you that the SIB URI here, which is IMS dot, for example, mobile network country XYZ, MC XYZ. Then here, this is SIB version, which is SIB version 2.0. So this is just in summary, this is just telling the BCSF I would like to register to the net. And the second one is via. Via, actually, this is just including the IP address. If remember, we mentioned that the user need to send his IP address to the network. So the IP address here, just telling them, please send me the response at this particular message. Then here you have something called maximum forward. This is actually, it's just telling like how many, what is the maximum number of hubs you have it here. What it means by maximum number of hubs. For example, as you know, the user initially will send the register message to the BCSF, right? Then the BCSF need to forward this message to ICSF, which is interrogating. Then again, he need to forward to the serving control or serving SCCF. And this is actually, each one of those is counted as a hub. So just the network is telling him, he knows that the maximum hub, he's telling them that maximum hubs you can take is 70, for example. This is not usually not looking into that much. And this one, BX is network information. Actually, this is just including information about the serving cell identity and also the RAT. For example, he's scamming an FDD, and this is the cell ID, which is telling them about his own information. So then the from one, this is just telling them about the IMBU. If you remember, this is the identity of the sender, which is IMS public user identity. This is also one of the information which is being sent. And the same for two, just telling them about which one you would like to call, and this is a public or IMBU for the mobile terminating, or the, you can see EUEB. Then you have something called C sequence. For example, here it's showing as one register. This is indicating to the network how many times you send that sub register. For example, assume he sent one sub register initially and it was not successful, he initiated another one. So this one will come as 2. If it's failed, we'll send another one, which will be coming as 3, for example. Then you have this kind of information within this contact. This is showing you the IME, so you can get the IMEI for this particular user from this information. Then here there's something called expires, and this is very important information. This is very, very important because actually this is, as somebody is telling you, what is IMS registration period. What it means by this? It means this is in second. For example, this 80,000 second. This means that the user need to renew his registration before the expiry of this timer. So in case if the user didn't send a renew, for example, assume that he's out of service or whatever, then the IMS will deregister the users from the network. So this is very important also during the troubleshooting. And also some of the information before that part. For example, this is the contact here. This contact actually is telling that this is the U address. It's telling about his address, his own address. And also one of the information under the contact one here, you'll find that this is here is saying that IMS ICSI MMMTEL is just stating that I'm supporting the services for like the MTAS, and also, for example, the SMS over IB. Here, this is kind of information is being stated here, but especially for the MMMTEL, as mentioned here. And here this is already being discussed. Then the last one, which is about the authorization, which is actually very important. As you can see here in this authorization, there is something called digest username. And this one, actually, digest username is including the IMB, which is user private identity. And here it's informing them that, okay, this is the address of the SCCF, for example, authentication center, which I would like to access, or I would like to get authentication, or I need to get authentication from the SCCF. Then it will be ending by this nouns. This will be later on also in the save register message, second one, or the 401, where the user will start comparing the information received by the network with his own information to confirm he's being authorized to access the network or not. So this is just in general what we have in the save register. And now the next one, which is about the 401, for example, unauthorized. This one will just contain something called nouns and other information, which just giving the information was being mentioned, for example, the numbers and random numbers and this kind of information, where the user need to compare to his own numbers to make sure that he's being authorized or not. He will compare. Once it's being equal, he will be sending a response back to the network or the sub register, which is a sending response about his own, as we mentioned before, signal response. As I mentioned before, the signal response that, okay, this is my response. After I compared, I found that I'm authorized to access the network. And once it's received from the serving CSCF, it will compare the same, and it will reply back to the users that, okay, with 200K, now you are authorized. So now that's what's being done. Now let's move to the last part of this session, which is really, really very interesting part. So the last part was covering the end-to-end high-level call view. So let's go through it and see what we have. So here we're going to explain the high-level call flow of the mobile originating. This is very important. So assuming the network now you have user A, okay, and user B. First one is originating and second one is terminating. So the first part here, you can see it's classified here. This is originating IMS, and this is the terminating IMS, and this is access network, which is the ABC and the A node B and so on. So the first thing the user will do, he will be sending the SIP invite, right? So the user will initiate the SIP invite message. So what kind of information will be included in the SIP invite? We'll go through the details later on in the next session, but just as a piece of information you need to know, there is two kinds of information in the SIP invite. Something called the SIP BART, which SIP BART includes signaling, and the signaling procedures. For example, it includes the URI of the SIP, the user B, is telling them, for example, this user B and the URI, for example, his address is for example, www.google.com or whatever. This is the first part. It's telling them about the address of the user in mobile terminating. This is and also it's telling them about its own address. Also, it's telling them this is my IP as well. You need to send the feedback at this particular IP. And the second part, it's about the something called SDB offer. What it means by SDB offer? Actually, when the user mobile originating initiate the calls, he need to state what kind of media type we have. This SDB offer is very important. SDB offer is telling them what is the media type, having two information: media type and the codec. What kind of codec being supported? So what is the media type? I'm telling them, for example, this is a voice call or a video call, as an example. So they assume that the media type will be saying that this is a voice call. And the second part, it's about the codec. Just one very important information: the user the negotiation will be happening in the call setup, during the call setup. So the MO users will announce that I'm supporting this kind of codec ranges. For example, I'm supporting wideband MR from 12.2 to XYZ, or I'm supporting Norband and wideband, and they will give all the supporting codecs by the mobile originating. So this is called SDB offer. So this message will be forwarding for the proxy CSF, and as I mentioned before, proxy CSF is the first point of contact. Then the CSF will forwarding the same information to the serving SCCF, right? And now, if you remember, we mentioned one function of the MTAS. The MTAS need to, why the SCSF is sent to MTAS? Because if you remember, we mentioned in the previous session also that the MTAS in general is handling the MO and MT call establishment. So what will happen here actually? The SCCF is for this one to MTAS because it will ask the MMTEL or MTAS what are the originating service are allowed for this users. The MTAS need to check if this user is allowed to originate a call or not. For example, is it possible that user is being barred from originating calls? Or, for example, the user found that his credit or his balance is being, he didn't pay his bill. So he's not, for example, authorized to make originating calls. So if he's authorized to make a call, the next step will be that the SCF now need to go and make a query within something called entities called DNS and the enum. DNS is referring to domain name system, and electronic number mapping for the enum. Actually, the main idea, if you remember, in the same invite, the user didn't send the IP address for user B, right? So still the HCF doesn't know what is the IP address. It doesn't know where it can send this kind of information of the same invite, right? So it's invoking or asking the DNS and the enum to start performing the query on the DNS based on the UB home. For example, this was a home domain, ub@yy.com. Then the DNS will resolve the terminating ICSF IP address. So this is the DNS main job, which is referred to domain name system, is to resolve the this domain into IP addresses. So actually, now this is the job of DNS. What about the enum? Enum actually it's can do something similar through that within the same invite. You will find also that the contact number of the mobile terminating is being shared. For example, the number or of this user is being shared. So the enum actually what it can do, it's like a protocol that maps this telephone number into internet resources. For example, it will map it into also IP addresses or something called SIB URIs. Tell them that this is the uniform resource identifiers. This is a URI, SIB URI. So both of them actually work together with the enum and DNS to facilitate the translation of the phone numbers or the domain or the domain, okay, into IP addresses and or CBURIs. This is the main idea about the DNS and enum. Just in summary, to resolve this UE number or the UE domain for the terminating calls into IP addresses, so the SCF will know where to forward the same invite. Then the SCF will forward, once it got the IP addresses, it will forward this the same invite to the ICCF or the interrogating CSCF for the originating network, asking them please start finding this terminating IMS for the especially for the serving SCF for the terminating users. So if you remember also one of the function we mentioned in the previous session, that one of the function of the interrogating CSF, it's working whenever there is an incoming call, especially from two different networks. It's working as the first point of contact in case of incoming call. For example, the originating call, when you initiate originating calls, the first point of contact was the proxy CSF, but the incoming call, it will be the terminating ICSF. So the terminating ICSF will send to the message, the same invite to the ICF, asking them, please, I would like to know where is the SCF for this network. Please interrogate and try to find which SCF is being served in the network. Again, it might be there is 4 SCSF, so it need to know which one we need to send the SCF. So once the terminating SCF interrogating the CSCF receive the call, it will just what it will do. It will go and query from the HSS. What queries make it ready to confirm what kind of which SCSF is being served by the empty user B. So it will tell them that the CSCF is, for example, number 1 or number 2 or number 3 and so on. So once it's being known by the ICF, it will forward this one for the ICF, SCSF from I to S, and it will follow the same procedures. For example, again, this one will go and query on invoke the MTAS, asking them whether this user is being able to receive a calls or not. So this is the same steps to just check whatever being done for the originating. The MTAS will do the same. That's why we mentioned that the function, it's the MTAS is supporting both originating and terminating call establishment. Then once being confirmed, then the SCF will be forwarding the same invite to the proxy CSF of the terminating users, and now it will be forwarding again the same message here. This will be routing here, and now this same invite will be including the user B and his current IP address actually, and the SDB offer which is being sent from a user. For example, the A user sending this is the media CS call, and this is my codec being supported. Now what need to be done from the user B? User B actually now need to check and send his also SDB offer as well, which is his codec. He need to say, I'm supporting this codec as well. This is a coding negotiation. So he will send, for example, I'm supporting narrowband. So both of them will check. If both of them supporting, for example, the highest codec rate, so the highest codec will be selected. And for example, assume that user A was supporting MR wideband, while user B supporting only narrowband. So in this case, narrowband will be selected. So this kind of negotiation to check what is the capability of the codec for both of them. So now the user B need to send a response, which is actually called something called the 183 progress, which is usually include the SDB answer. And this is telling them this is my supported codec, and this is This is a provisioning response, which is indicates what kind of coding is being supported. So it will again move back until it's being received by the users here. It's being above here. You can see it's received the 183 session progress SDB. So you can see now the blue dotted line. This is the sequence, which is usually the signaling will be followed. But all of that till now, the call is not, the dedicated beer is not being established. All this was passing through the QCI 5, right? Which is a default EPS peer, which is only for the step signaling, right? So once he received this offer, will be another response. We'll be discussing details in next sessions. For example, sending the response and so on. But assume all the steps are being done, ringing being sent and so on. Now, in between, the dedicated bearer will be created between the user B and user A, which is through the QCI1. And now the RTB media can flow directly from the user A to user B through this access network through the QCI1. We'll explain in details how this can be done. So the RTB media is established directly between both of the users using the agreed SDB offer or parameters in general, which means in summary what kind of code is being supported. So this will be transferred over here. And actually, this was the last part of today's session. I tried to make it in less time, but it takes around 45 minutes. So I hope if you like the contents to like and share it with your friends and stay tuned for the next video. Thank you very much and see you next video.